I am first sharing the question and let's discuss on that later. Okay. So
Hmm.
you have a array which contains all integers
Okay.
and a target sum is given. Means target number any value is given to you. That is also an integer. Now you have to find the sub array. Basically sub array means contiguous part of an array, you know that. So you have to find the minimal length of such subarrays, or I can say minimal length of that specific subarray. So there can be multiple subarrays. Like you have solved one question. So here in this problem, you have to find the minimum of the minimal length of those subarrays which satisfies one criteria, and the criteria is the or constraint is the sum is than greater than or equal to the target given to you. So that sum is always greater than or equal to the target, and if such subarray is not present, you should return 0. And this is the problem statement given to you. So you have given a positive integer. Let's change that question first. Let's say this is an integer. So and it is not given as okay, this is an positive integer, and the array can contain positive or negative.
Okay.
Hmm. And you have to always find, oh, I am giving one example. Let me copy it. Yeah. So let's say the input as 7, sorry, the input array is this one and the target is given as 7, and your output will be uh, the subarray which contains the minimal length of the subarray which satisfy the condition. Here you can see 4 and 3, it sum up as 7, and which is as given as the condition greater than or equal 7, which satisfies the condition. So it will be your expected output. So you will return that length of that subarray, right? So you have to find the minimal length, not the subarray. Okay, I am adding that too. So you have to find the minimal length and the subarray itself. Means you have to print the subarray also. Print the
Okay.
subarray which satisfy this condition. So let's start with brute force. Okay, for now, take it as a positive only. Then we will discuss what will happen if there will be negative as well. Okay, so write it the positive. For now, take it as positive. Okay.
Okay. Uh,
So
I
what
mean,
will
if you
be?
want,
Let's start with the brute force. So what will be your brute force solution? Can you please tell me?
so we are gonna start from the beginning, just from here. Then we, our one pointer is gonna be at the beginning, and the next pointer will be begin from the next position, and we are gonna check if we can find anything that gonna sum up or greater than the target. So if something finds out, we are gonna keep track of that. And if let's say if one of the integer in the array, if one of the value in the array is 7, then we are going to keep track of that. Like if 2 and let's say 4 and 3 is one of the solutions which sum up to 7, but if there is another one, let's say only 7, then it's going to be another solution. So we are going to keep track. In one hand we are going to keep track of the length of the sub array,
Sabaris.
and in another part we are going to also keep track the starting position and ending position.
Hmm.
but it's gonna be big O n square solution because we have to keep track of the starting position and also the ending position to match the
Hmm.
target. That's the brute force one.
Yeah. So in brute force, we are possibly finding all means we are finding all possible such sub-arrays, and sum up means sub-arrays, and they and we check the condition that that sub-array uh, means you are summing up the elements for that sub-array, and you are also checking in if condition that if it is match the given criteria or constraint. So yeah, so it's the brute force is quadratic. So can you write the brute force one? So let me give you the template. So you have given a list and the target. So
Mhm.
yeah, can you write the brute force?
I need the edit access. I can only view.
Oh, just wait. Edit. Yeah, now you can write.
Let's see. Okay.
So for brute force, all possible sub-arrays like problems, the thing is that you have to find all possible sub-arrays.
Yeah.
So that will be the brute force, and it is common most of all sub-array problems. So you have to find the all possible sub-array present in that array, and then you have to compare some condition given to you. Like you have to check the condition satisfies or not. So yeah, it's almost brute force is I found almost same in all such problems. Yeah. So write this down. Yeah.
So if we are gonna start from, let's say, at the beginning, so we don't have any specific length. So
No, no. Uh, the nums array has a length.
no, okay. Sorry, this one. No, I was saying like uh, how far we are gonna go.
Yeah, so that means, yeah, I understand. Like that subarray, the resultant subarray can be the length of whole subarray itself. So the whole subarray may be satisfy the condition. That means, so let's say the whole sum of all the elements in that array contain
Mhm.
means satisfy such condition. Let's say what is the sum of this array? 6, 8,
15.
15, right? So let's say this is 15. That means this itself a solution. The whole survey itself a solution. Only one possible solution is there. So that can be the solution as well, right? So the whole array itself, and the subarray means all possible such combination of that array. So the whole subarray itself means whole array itself a subarray.
Well, the one loop is running from here, another one is running from, well, it's gonna be I plus one, and we cannot add the same number, so it has to end one. I mean, I'm gonna run first loop from here to here, and the next one is gonna run from 3 to the end of the index, because as we are not gonna take considering the same number twice in the count. So that's why I'm uh, ending the first loop on one index before and beginning the second loop
Hmm.
after I. So our condition is if nums of I plus nums of j, if both of them is greater than, I mean, we don't have any specific target, but it has to be greater than or equal of target. So this one, then we are going to consider, okay, we found a candidate. And let's say we want to find the minimum length. So
Hmm.
let's say we are going to initialize the mini with the maxi value. Let's say it's in Python, it's infinity. So this is going to keep track of the
So you
mini.
have taken the length as infinity, okay,
Mhm.
and you are running the loop.
uh, Running the loop from the second index to the end of the index and checking if 2 plus 3 or 2 plus 1 or 2 plus 2 is any of this matching with the greater than or equal of the target. That's one thing.
First write it. I will correct that.
Okay,
Yeah, whatever you're
so
saying, try first try. Yeah. So what will be the length of the subarray? So let's say
okay, the
j is
length
the
of.
end, and
Mhm.
what will be the length? J. What is the starting index here? I. So j minus I plus one. This will be the length of this. Means whatever you are writing. So for your, so this will be the length, right? J minus
Yeah,
I plus one.
but that's not going to be contiguous. That's another problem. I need to keep track of the total of something
Yeah.
because the
So
way it's going,
you
two
have to
one two two is not contiguous. So that's another problem.
yes.
So you have
So
to,
you have to summing up all the numbers,
yeah,
subarray
yeah.
numbers. Yeah.
So I have to keep track of the nums of I plus nums of j.
Oh, why nums of I plus nums of j? Why not only nums of j?
Hmm. Wait. Oh, okay. Nums of I is constant. We don't need to, bringing
No,
it again and again.
no, I do not understand why nums of I is constant. So nums of I also change. Yeah,
This pointer
I.
is constant.
Yeah, for
Yeah.
let's say for first iteration, so I will be
Hmm.
always at zero. So j you
Yeah.
are why j is I plus one. You can also start considering the same index also. So let's say j starts from I itself, so that means zero. So let's say
Okay.
j starts from here, and you are summing up all possible, means you are uh, for I zeroth index, you are taking all possible subarrays. You are finding all possible subarrays here. So 2 3 2 3 1 2 3 1 2 2 3 1 2 4, like, right?
But
Yeah.
yeah.
And how you are doing, you are summing all this means when you are doing the sum here, it's basically a cumulative sum, I can say.
Hmm.
So 2 3 2 3 1 2 3 1 2. So that means you are summing a cumulative, it's basically cumulative. Or when we solve the prefix sum, so like that you are summing up all such consecutive elements, right?
We are
And
going for the brute force.
yeah, yeah, we are doing the brute force. So I am saying that
Okay.
it's kind of cumulative sum only. Yeah.
Yeah.
So if the total greater than equal target, yeah, write it.
Hmm.
If the total is greater than equal the target, and the condition is same. Yeah, this is the condition. If j minus I plus one, that is a mini I, you can say mini I, why mini length. That's more meaningful, right? Mini length. And at the end you return that. And but you have to also check, let's say the sum is not present, right? If sorry, the subarray is not present, right? Then you have to return zero in that case. So you have to check if that mini length is not even changed, right? So
Yeah,
if
we
it,
can we can we
yeah,
can check it at the end. Like if the mini length never been changed from
yeah,
infinity,
yeah, yeah, then you
then we
return
can just check.
zero, else you
Yeah.
return this updated mean. Yeah, so write that. And we have another thing here. You have to reset the count for every iteration. So we
Oh
have
yeah,
to
we need to count the number of.
target will be reset. Target will be again 0 for every iteration.
Oh yeah.
So here, sorry, target I am saying total will be 0. So for every iteration, the total you are starting from the for new servers, new positive new possible servers. So you have to reset it again to 0. Yeah. So let me check again. It's one total. I'm not checking the syntax. I am checking the logic only. Okay.
Okay.
So range function is doing cumulative sum if total is second target mini len. Yeah, so that's fine. After that, users return.
This should be
Yeah,
okay.
mini len.
That's
Yeah, yeah.
yeah. I mean, we are gonna return the min length if it's not float infinity, else zero.
Hmm. Yeah, that's it. So, what's the time complexity and space complexity for this solution?
I mean, we are not using any space. It's a
Hmm.
constant.
Constant. Yeah.
Big of big of one, and the time complexity is of n square because we're, we are using two loops here, and every time.
Yeah, we are possibly finding, or uh, miss, we are traversing for all possible subarrays. So that means it's n square time complexity. N is the length of the array. Now, can you optimize it? So, can you do a linear time solution for this?
Using the
We,
only using
yeah,
only considering the positive.
yeah, we are considering only the positives.
Okay,
I think
so
last day I told you like, uh, if there is what means when if there is all positives are, or if there is positive and negative, which approach
yeah,
you should
yeah.
follow.
I think the last day one was only slight difference was there was only we are considering only k consecutive integers.
Yes.
So here we don't have any boundaries.
Yeah. It's basically a
So
variable length
yeah,
summary.
so if we consider this one, if you want to do it in linear time, then
Hmm.
we're gonna running a loop from the beginning. Then we are gonna add whatever is the every index value. If we found something of total is greater than equal target, that means, and if we consider only positive, then regular sliding window two pointer technique is good enough. Starting position is going to be from zero. Instead of saying I, we can say it's R, which is the right index of the boundary, and we can add R here. So if any of this time total is greater than equal target, so we found a possible candidate. Let's say mean length is going to be the mean of mean length and R minus L plus 1. So that's a possible solution. Another thing is we need to update the left pointer.
Hmm.
So that's going to be L plus 1. So let's see if we go from here to 3, 5, 6, and this is 8. This is one solution.
Yeah. First, let means tell me your approach, and then jump to the
Okay.
coding.
And
You
this
just
is
write it. Yeah,
this.
you can complete your code. Yeah. Then we'll discuss.
So if this is where we are gonna get a solution of mean length. If and let's say we are gonna find the and do you wanna count the are you gonna count the number of Savere too?
No, no,
Total
no.
number of
Here
Savere?
only one minimal length will be present, right? Means I am find means the question asks us to find the minimal one. There may be multiple subarrays present, right? Having that
Yeah.
target sum or greater than the target sum, but we have to find the minimal of that those
Yeah,
length.
but what
Yeah.
about there is one is 4 3, another one is 5 2. So I was asking like we need
Oh,
to
you can say yeah. Then that means the length will be same, right? So you just return the
yeah, yeah.
length.
Okay. So then
If
mean length is good enough for this.
yeah, yeah. So let in the next problem when we have to print it, we have to print both of them. For, yeah.
I mean it's gonna be the same thing like this. We figure out a mean length, believe. Yeah.
Okay, you have done, but I would say that this solution is you are means you are in
Okay.
right
Well,
track, but the solution is not
yeah,
correct.
yeah.
Yeah.
Because when we are updating the left pointer, we are not removing that left value from the total
Yeah.
because otherwise it's gonna increase and increase. It's never gonna.
Yes, yes, because it's all positive, right? So it will always increase. Yeah. But I
Yeah.
have few
This one.
questions. So let's say you are running the loop, the outer loop running from um, the right pointer, right? So it's running from 0 to total length, whole length, and you are summing the cumulative sum. You are taking the all Savere sums, and you are checking if the sum is greater than the target. Then you are taking you are computing the length of that survey, and you are also comparing if that is the minimum, and then you are removing the beginning element from that survey and
Yep.
incrementing the left pointer, and then what you are doing, you are not incrementing the right pointer.
It's a for loop,
Oh
so it's
yeah,
gonna
yeah.
increase.
Inside the range only, even range function it will work. Yeah, that's fine. But what happened? Let's take an example. So you are removing only one element from the beginning. So let's take an example. Same example. Let's take. Can you dry run with this example? Give me. So
Yeah,
yeah.
sure. So our left pointer is at 0, so it's right now at 2. And the right pointer is also at 0, so it's the total is 2. Next time is gonna be 3 plus 2, 5, 6, and 8. This is the first solution we are gonna come up with mean length.
Yes, four. That means four.
So the mean length is gonna be 4 at first,
Yes.
and the total is gonna be 8. And this
To,
time the right pointer is gonna update to 1.
total is eight. So you can write here. You are just removing the first element right here. So it will be
Oh
four
yeah,
minus two.
2.
That means
8 minus
six.
2 is
Yeah,
6.
8 minus six. Six. So now it does not. So you are again comparing.
So next time
Hmm.
we are going for, oh my bad. What was the, okay, yeah.
Yeah.
So next time is going to be from 3. From the left pointer is going to start from 3, and the right pointer is going to be here.
Hmm.
So 3 plus 1, 4, 2, 10. This time is going to be 10, and the length is still going to be 4. But if we're going to consider 10 minus 3, which is this, so left pointer is going to be updated to 2 now here, and my right right pointer is going to increase to here. So 2 plus 1 is 3, 4 plus 3 is 7. Here we found another solution, but already we incremented our right pointer. So it's another one at the end of the array.
Yeah, your
So,
voice was breaking. Can you repeat again?
so I was saying our left pointer is going to be here,
Yes.
and by the time right pointer is here. So
Yes.
it's 2 plus 1 is 3, 4 plus 3 7, and 10 is going to be another 10, which is also greater than target.
Hmm.
There's another mean length, and
What is the length of that subarray?
it's going to be 1, 2, 3, 4, again 4.
Hmm.
So if we increase that one, left pointer is going to be 10 minus 1, and left pointer is going to be 3. But by the time we are running out of loop, because the right pointer has no other option to go forward, and the min length is still going to be 4. But yeah, there is a problem.
Yes. There is a problem. We
So
did not reach the expected output. What is the problem? The problem is here. You are only removing the only single element, but there should be, you have to remove all possible elements until means you have to check, if means you have to start removing from the beginning of that subarray until it break the condition. So until,
yeah, yeah,
yeah,
yeah.
so you are
It's
only
going to be a
removing a
while.
single element from the beginning, but you have to
Yeah, because
remove all the possible elements from the beginning until this loop will break, right?
yeah,
So because
yeah,
we are finding the minimal, right? So you have to remove all possible elements from that subarray. You are only removing one that will not give us the expected output here.
yeah. It's going to be a while loop.
Yes, it should be while loop. Can you try to dry run again with this
Let's
code?
say, yeah, if we consider this one, our let's say this one is here, right? For the last input,
Yeah.
1 and 3, right? So it's going to be 10 minus 1, which is 9. And my right left pointer is going to be updated to index 3, which is this. 2 plus 4 is still is going to add, I mean, 2 plus 4 is 6 plus 3 is 9, which is still greater than target.
Yeah,
And I mean, length is going to be updated
by 3, right?
by 3. But by the time it's 9 minus 2, which is 7, this is going to be updated to 4. And when it's 4 here, 4 plus 3 is 7. This is going to update again, the length is 2. And by the time it's going to come here to total, it's going to be 7 minus 4, which is the left pointer of here, which is 3. And left pointer is going to be at 5, 0, 1, 2, 3, 4. Sorry, I missed 5, yeah. By the time it's coming here, it's only 3, and it's breaking the loop because total is less than the target.
Yeah. So yeah, this is correct now. Now the solution is perfect. What's the time complexity and space complexity for this
I
solution?
mean, it's constant. Its space complexity is constant, and the time complexity is big of n because we are doing the linear operation here using the two-pointer approach. Big O
Yeah,
of n and
it will
big
be
of 1.
linear, and the space complexity also constant. Okay. Now, um, this problem, there is another way to solve this problem. The that For that solution, it takes in login. We can do a binary search here.
Mm.
How we do binary search? Basically, we are means that's in login. We are already in optimized solution, but I am giving a intuition how to solve using binary search. What we will do,
Okay.
we will find all cumulative sums. Every elements are positive, right? If we find the
Yeah.
cumulative sum or prefix sum, it gives us increment or monetarically incrementing, right, summations, or
Yeah.
right. And that is already, if I take the cumulative sum of that array, it is always in increasing order, means always sorted, I say, ascending order, ascending order sorted, right? So
Hmm.
you can do a binary search there to find.
But the value, I mean, the value is not sorted, right? The
No, values
nums
are
array
not
is not
sorted,
sorted.
but the summation of those uh, s- elements will be sorted in ascending order. So if you sum up these values, so always it will be increasing because all the elements are positive only. So based upon the cumulative sum of these elements, we can do a binary search, and that gives us in login. That's not optimized, but yeah, we can do. But it is not intuitive, very much intuitive. Basically, if you can see, the array is not sorted, but their cumulative sum is sorted. So
Yeah.
based upon that logic, we can do a binary search on it. So yeah, we can solve using binary search on uh, using binary search also. Now the problem is, oh, okay, so we have not done the second part of that question, to print the subarrays.
Yeah, we
Can
can,
you,
we
yeah.
can, I mean, every time we can, what we can do is, let's say this is the result of the list. And then what we can do is left pointer plus, I mean, in Python, the boundary is, right pointer boundary is going to be r plus 1 because, so yeah, every
It will
time
be
the min length is
inclusive or exclusive?
r plus 1 is the exclusive one.
Okay.
It's going to be from the left pointer till r. So if you want to consider, let's say, index till 6, we have to give 7.
So resultant list is containing all such subarrays, right?
No, it's only containing the updated one, which is the number, I mean, two length of 4 and 3. It's not considering everything. But are we going to consider every subware?
Yeah, we are
Okay.
printing all possible subarrays. Or yeah, for this problem, yeah, find the minimal one only. So let's say there is five for this problem. Let's say 5 and 2 is also there, which contains which satisfy the uh, condition, right? So 5 and 2
Mm-hmm.
and 4 and 3 both should be printed.
Okay. Okay. So, okay. If we find now there's sorry, not yet. So let's say we found 1, 2, which is this.
Yeah, you
And
can take
then,
some time. I'm coming. Okay.
okay. And considering each possible candidates as a separate list. So that's why this
Yeah.
is,
Can you write down with your code?
yeah, sure. So let's say this is 2 and 3, 1, 2. This is a possible candidate.
Hmm.
So it's going to be like 2, 3, 1, 2. That's another solution. That's one solution. Next is gonna be 3, 4, 2, 6. This is another one. 3, 1, 2, 4. 3, 1, 2, 4.
Hmm.
Another one is gonna be this one, which is 7, 1, 2, 4. Another one is gonna be 2, 4, 3. And the last one is gonna be 4 and 3. Yeah, this will be like this.
How extends was it? So it contains all possible subarrays, right?
Yeah.
I miss we need only the 4 and 3, right? That output,
Yeah, but then we
the
are only
minimum one.
considering the,
Yeah.
I mean, that time is gonna change, right? The question is gonna be only equal to the target. And if we only considering to the target, then this is gonna be only this.
No, no,
Then
no.
it's only gonna,
Our target means the question asks as to minimal length. So here in this case, the minimal length is 4 and 3, right? So the first we have solved the length, right? So
yeah.
the length is 2. So when the length is 2, we need the subarray only. So here the 4 and 3 satisfy that subarray, right?
Oh, okay. So
Yeah.
we are saying minimum of minimum. Then
Yeah.
then it's gonna be another if condition. Like if the mean length is what we are getting from here
Without
less
no,
than.
no, I'm saying that without using the mean method, if we use if, can you do that?
Yeah, that's what I'm thinking.
Yeah.
Like every time the mean length is gonna be updated.
Hmm. Yes,
So
but we do not need to print every service, right? So
yeah,
we need
we are
only
gonna
the
just
mean out expected outcome.
what we can do is like if we are saying this is, let's say this is the,
Yeah, comment that and use a if.
yeah, I'm using if
Yeah,
here. I
if
mean,
yeah
we
if
need to come. I mean, this is. I'm thinking like this is what it is right now. It's fine
yeah for the
because
first part of the question it's fine. So
yeah.
if
So the
mean length
next
is
part
less
is.
than r minus uh, r minus I plus 1,
Hmm.
yeah, you write it there. If mean length is r minus less than, write it r minus r minus I plus 1. So what you have to do, if that is length is lesser,
Mm.
you are not appending, right? You can override that existing um,
I
list
mean, extension is gonna work fine because we have considering two subarrays now, 4, 3, and let's say 5, 2.
5 2,
But
yeah.
if we put the append, the output is gonna be like this. Let's say 5, 2, 4, 3. But this is not what we want, right? This
No,
is an individual list. This is another
another
individual
list,
list.
yeah. We need a separate
So,
one.
yeah, that's why the extend. That's how the extend works.
Hmm. If yeah,
This time for the first one is 4. Okay, let's say it's 4, but it's the same. So it's not gonna put anything at the beginning for the first length of 4. Next time when it's 3, still it doesn't make sense because mean length we are getting is from the r minus l plus 1.
Hmm.
So every time the mean length and r minus l plus 1 is going to be the same because mean length is updating based on the left pointer and right pointer.
Yes, that's correct.
So in, then it's going to be 4, 3.
Yeah. What you were thinking? Just tell me.
I just thinking like, mm,
Take that
uh,
example. Go to the example. So try run once again. So how this logic means your code works. So we have to change the existing code only. We do not need to write another logic or write some another algorithm here. So we have to work on the same code, but we have to add few logics. Okay, not any extra algorithms or patterns are here using. It's already we are using sliding window. Just we have to print that minimal length subarray. So you are finding the minimal length. While finding the minimal length, can you print that? That's the question.
one way is to, I mean, if we are only considering that there is only one value, then what we can do is every time we are entering here, we are just gonna making a new list, and as I'm just saying, because there, so it's gonna be like res dot append.
Then you are again resetting the rates for next iteration, right?
Yeah, I mean it's gonna append every time. Then for the first one, then it's gonna be a for the next one, it's gonna be a new list.
New list.
It's gonna,
Then
yeah,
let's say
removing.
4 and 3 and 5 and 2 are coming. Then it will only print any
Yeah,
either of
it's gonna be print any of only one of them.
one of them, but we need both of them.
Yeah. So what
We
we can
cannot
do is,
reset that, right? We cannot reset that.
I mean, what we can do is, if mean length whatever is now,
You write using if condition. If mean length less than or equal r minus I plus 1
what
means
about
write
what
as
about
if
keeping the mm, I mean keeping a point, I mean keeping track of the previous, what about keeping track of the previous mean length and then update it and put it in the result? Like what I said is, let's say this is the initial mean length, right?
hmm,
So I'm putting it into the result. For the first one, it's gonna be this. then I'm saying let's put this somewhere in the previous mean length, and
You can do simple list of list you can take, and you can store their list of list, right? As a list of list.
no.
Here I there is no constraints of taking any extra spaces, so I you can take extra spaces as well.
No, my
uh
point was,
hmm,
let's say, I mean, initially the previous, let's say, mean length
what
is
is
4, right?
yeah,
And we did not initialize anything previous. Let's say the
yeah,
previous is gonna be the same as infinity. So initially, if we put infinity, the first, if it's only the first result, then it's not gonna count. But there's gonna be a problem then. Okay, wait. Previous is gonna be the same as mean length. So this is going to be the equal of this. So the first result is going to be the 4 index of, what is the 2312. Then the previous length is going to be 4. Now the new while loop comes is going to be 3, which is less than the previous. Then the new one is going to be 3124, 312. Then the next one comes as 2. Let's say 52. This is 52 comes in. The problem is going to be when it's going to comes for 4-3, the list is going to be again initialized with the
reset
new
again,
list.
yeah, it will reset again.
Yeah, every time it's going to reset, it's going to be a problem then because this time it's only, yeah, same problem.
So how you have to resolve this,
Yeah,
because this question is asked in many companies. It's not in lead code, but it's a variation. I can ask in my interviews, right? So it's
mm,
very easy for this. So when I say it's a sliding window problem, yeah, anyone can solve. Like, but when add some more constraints, it will be difficult.
yeah. This sounds kind of little bit tricky. Yeah, I mean adding this if they're, I mean usually in the sliding window they always have the unique values as a result. Yeah, if you put I'm kind of stuck somewhere.
Yeah, you can think again. It's a beautiful question. We'll discuss in the
Sorry.
next. Yeah, you can think again on this. Okay,
Mm-hmm.
and then I will share the solution. First,
Okay.
yeah.
Okay.
Okay, now let's say there are not only positive.
Just give me one
Yeah,
minute.
yeah.
I'm coming back. I just need to do some. Just do 1 minute.
Or do one thing. Already late. We can continue in the next class. That was fine.
Mhm.
So I'm giving
Or you
one.
can give me the next question. I can think about it.
Yeah. So the next question is the same question only. I am giving. I am saying that there is not only it's given as positive only, right? So I am
Hmm.
giving that there also contains negative. So both can be there, positive as well as negative. How can you solve that problem? So this is
I
one
mean,
very
in that, I mean, in that case, this one will not work
will not work because.
because the total is not going to be the monotonically increasing.
Hmm,
There will be some ups and downs.
hmm,
So the regular sliding window will not work. We have to go with the prefix sum considering a dictionary.
yes. Yeah. Okay. That's fine. And it's, yeah, you said it correct because uh, it's not on always increasing or always decreasing. So sliding window will fail to identify, like you have to sync the compress or expand. So
Yeah.
that's why this sliding window will not work. We will discuss. Yeah, try to
Yeah, I'll
yeah,
try to solve this
yeah,
too
try
and
to
share with
solve.
you.
And
What about
also, yeah,
uh, what about the other solution that I shared? Was it
yeah,
okay or
I need to go through it. Can
okay?
you, yeah, for that solution, can you add some comments in it, like that solution which you have shared? I opened
This
once.
one? Yeah, I shared this one. Yeah. I mean, I put some comments like this is only for find if there is subarray. I mean, the first one, if there is a possibility of finding a
Yeah,
possible
yeah,
subarray. This is the first part.
yeah, yeah,
This is only works. I mean, this only considers when there is a positive value if the sum is present, and only for positive values. This condition,
yeah. Okay.
and this one is for the negative one. Only the total signs. I mean, this decreasing